Okay, so let me just quickly, again, sorry guys, good morning. First thing first, we start from page 77. We say that in Python, all non-zeros are equivalent to true and zeros are equivalent to false. If you have one number like 42, you can just convert it simply by saying Boolean, convert that into true, and you can convert 0 into false. And now, because you have entire one true, one false, you can simply say true and false, or true or false, right? Does that make sense, everyone? But look at this one here. What if I have an array of numbers, or in binary, we have 1 0 1 0 1 0, and we have 1 1 1 1 0 1 1, right, Ashad? In that case, if you say and, what's going to happen? It's going to take the first bit of first number and first bit of second number and just try to AND them. And here is going to be the result of that. If you use, instead of this type of AND, if you use A and D, that kind of AND, it's going to raise error. The same applies to this one, guys. Everybody, please try these two lines. And if you say capital A or B, it's going to give you a bunch of truths, or here it's going to be true, 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 except this one, which is false and false, right? The rest would be truths. But what if I say this type of OR? Anybody can guess what's going to be the result? Error. Exactly the same error that we got a few seconds ago, value error. And here we have value error. Because it's not one entirely one value and another value that you can say this is true and this is false, and what is the result? Or this is true or this is false, and what is the result? Does that make sense? So now, if you paid attention, you can answer the other question of the quiz as well so far. And let's see. Okay, how about this one? Among all those values that we have here, everybody please try these two lines. How about using this type of AND? Again, the same error, value error. How about using this type of AND for those who worked with other languages like Java or C#? Exactly, but this time it's not going to be value error, it is syntax error, right? Now you have the third answer as well, third question. So, yes. Syntax error is more of a Python error or NumPy error? Which one? It's Python. Yeah. Because we didn't specifically say anything about, we just use this. And anyway, let's just go to the next part together, and that is fancy indexing. And fancy indexing, my suggestion, those friends that they try at the same time, copy and paste these lines, because we all use random state 42. We should get, all of us should get these numbers, the same set of numbers. Huh? I'm going to switch to my NumPy file. Simply, you can copy paste from the book. There we go. Whenever you are done, please give me a signal so I can continue. Thank you. Merci. Awesome. Lovely. Bravo. Excellent. So look at this one, please. Here we say, I want to have random integer between 0 to 100, not including 100. And how many random numbers? 10. You can say I want index number 3, 0, 1, 2, 3, so 71. Then 4, 5, 6, 7. Here it is. And then index number 2, 0, 1, 2. Here's the one. That is one way. The other way is saying, hey, let's have all the indices in one variable, like int, and then pass it to the index, to the array, all of them at once. So it's gonna just bring you all those values. This is what we call it fancy indexing. Okay, please try it. Take your time, and whenever you're done, give me a signal. Peter, did you get my? Okay. Okay. No worries. Okay. Now, those who want to copy from the book, it's page, as you see, 79. It's here. And this is normal indexing, and this is fancy indexing. What it actually said here is the shape of the result very much depends on the fancy indexing. Imagine that you create NumPy.array 3, 7, 4, 5 into a matrix like this. And the output would be something like a matrix that you see. Now it is 2 by 2. Please just make it 3 by 3. Add 2 random indices and make it 3 by 3. Whenever you are done, please give me a signal. Done. Awesome. Okay. How about this one? Everybody use this command to generate a matrix from 0 all the way to 11, 3 rows, 4 columns. And then I didn't grab why we have this result for this one. The best is if you can just go through it yourself, spend a few seconds, explain it to your neighbor, and a brave person explaining to the whole class. By the way, thanks for the presentation. Good presentation, Mahir. Good presentation for assignment 1. Negin as well. You too. Okay, anybody is volunteer to explain? Yes.
So I think it will like be like one column. So for the first one, it's gonna be row with the index of 0 and column with the index of 2, which is gonna be 2. And for the next
Let me just ask you one thing. So this is our, what do we call it? This is our matrix, right? So what does it mean? It gives us 2. So 2 is a result of what numbers?
So it's 0 and 2 for the first one.
0 means that row 0, which is this one,
Yeah.
and column
The column,
column, no, it's going to be column 0, column 1, and column 2. So it's going to be, my apologies. So it is going to be this number 2 that we have it here. Okay. How about 1 and 1?
the next one will be like the row 1, so it's the second one. And the column 1 is also the second one, so the result will be 5.
5.
And the third one will be row 2, which is the third row. And the column will be 3, so it's the fourth row, and the result will be 1.
Okay, awesome. Everybody got that? So by saying that, now we have something different. This one we said, thank you, Negin. This one we said row is everything but in one column. So that's why we have it 0, 1, 2. And the column is the way that it was before. So 2, 1, 3. But what if we say, let's have this one and this one? What would be the result? Explain that to your friend. Let's have 2 minutes for it. If you want to copy from the book and then start working on it, it's the beginning of page 80. It's in here. Okay, if you explain this one to your neighbor, you're gonna be prepared for the next question. Casey, do you want to explain? Oh, okay. Anyone else? So how about this? Look at this one. It's not that difficult. Here we have rows and columns. And look at the result when you apply it to X. If we say 0 and 2, what does it mean? Means that row, yes,
So it should, sorry, the rows and columns should be expanded to a 3x3 grid, right?
excellent, yeah.
So then, when we apply that to the capital X array, which is like 3x4, right? It would pull, well, it would be a 0 and then I guess 3, or sorry, 0, 2, because 2 is the column. Row, so it would be 0, 2, 0, 1, 0, 3, and then 1, 2, 1, 1, 1, 3, 2, 2, 2, 1.
The thing is, I simplified it for myself like this. We have 0 here, means that row number 0, and then row 0, which is going to be, if I want to show everything in here, row 0. Then what are the columns? Column number 2. So if it is 0, if it is 1, 2, and 3. So 0 and 2 is going to be 2. That is why we have it here. And then the next one is 0 and 1, which is going to be 1, and we have it here. And the last one is 0 and 3, that we are going to have that 3 in here. Does that make sense? And we do the same thing for row number index 1 and row index 2.
So if we just change the values of the column array to 0, 1, 2, 3, it would pull the entire thing.
Column or
Yeah,
rows?
yeah, because we only have 3 rows, but we have 4 columns.
Yeah.
So if our column array instead of 2, 1, 3 was 0, 1, 2, 3, we would pull the entire thing and it would be a shift.
True. True. That is why I mentioned that the shape of the result, it very much depends on the shape of fancy indexing. So because the fancy indexing here had 3 by 3, then the result would be 3 by 3. Although the original had 12 values. Good question. And the same way, if you have those numbers, let's just have paint. Or maybe the best is using Excel. It's easier to actually, I provided the values here. What was the row? It was 0, 1, 2. And what was the value for column? It was 2, 1, and 3. I'm sorry, 3, right? So that is why if you just multiply these two, it's gonna use broadcasting mechanism. So it's gonna expand it to 3 columns and this one 3 rows, the result would be something like this. If you multiply rows in a kind of vertical form and columns. Okay, so how about this one? One column, and then 2, 0, 1. Yes.
So it's gonna take the second row because it's 0, 1.
Takes the second row and the third row, right? Awesome. Yeah. What else? So it's gonna be, what are the numbers for it?
So 2, 0, 1, it's the second index for the column, which is 0, 1, 2. So it's gonna be 6. And then
First thing first, we start from here, right? Because it's index 1. Okay. And what is 2?
that's gonna be the second column, which is 6, 0, 1, 2. And 0 is 0, that's 4, and then another one is 1, which is 0, 1, which is 5. And then the same thing for the other one, which is 10, 8, 9.
10, 8, 9. Bravo. That's pretty much it. So I just go with row index 1, which is this row. And then you're gonna pick column index 2, which is going to be this one. Column index 0, which is going to be this one. And column index 1, which is going to be this one. So 6, 4, 5. And these are the values that you see here. The same thing for the last row. I don't repeat that. So if you just check what are the rows, and what happens when you say row, you remember we said it's all the rows, but one column. We replace it with number 1, right? How about this one? This is something that I couldn't very much understand. So I want you to spend a few seconds with your neighbors, discuss this, what's gonna happen. Apart from explanation, I want you to provide a simpler version of that because I couldn't grab this. Simplify the formula, please. In a few seconds, sure. Okay, please.
I understand what's going on, but I'm not sure exactly how you want to make it simpler, but also you want me to just go out it what it's doing, or what would you like me to do?
Oh, actually, that's my concern as well. I couldn't understand what is happening here.
So once it gets expanded, the based on mass, row and mass come together to make another array of 0, 1. It's pulling from capital X in like different coordinates, like or with sorry. It's using the fact that it's either Boolean, either true or false, 0 or 1, to decide which pieces to pull. So it'll pull at 0, 0, 0, 1, 0, 2, 0, 3, but it will only pull when the Boolean is true.
That's exactly, good try. That's exactly what I was missing. So whenever it is true, it means pick that part.
Yeah.
Whenever it is false, means I don't want that part, right? Okay, Megan, you wanted to say something?
I understand, this is, we want all the rows. And except on the rows for the columns, we have 1 0 1 0, so we want to keep the first column and the third column. And we just eliminate the second and third, because they're gonna be small, and the value is 0. So we're gonna keep the first one, which is 0 for A, and the third one, which is 2 6 10.
Okay,
And plot all the rows, so that's how it is.
so based on what Owen and Megan said, let me just summarize what you two said. For this one, mask is responsible to say true, false, true, false. And by saying that, whenever it is true, we are gonna pick that part. Whenever it is false, we are gonna just ignore that part, mask that part, right? Hide that part. In this one, it says array X. Go to all the rows 0 1 2, because the value for row was 0 1 2. Go to all the rows, and the first column, not second, third column, which is going to be 0 for 8, and then 2 6 10, means just these two columns. Does that make sense? So now you are just one step away from summarizing this formula. Just please summarize. It's very simple.
So we can write X in a bracket, 2 dots and mask.
Lovely. That's what I wanted to hear. Maharshi. Here is the answer. Yes, you can simplify it by saying column is all the rows, but just those two columns. Does that make sense? Right? Okay, no. Now we are ready to go to this random point, but this part actually needs to know a little bit of math. If you look at here, and you're gonna have this file, so just if you enjoy knowing the science behind what we are doing. This one is just 3 minutes. This one is, if I'm not mistaken, 7 minutes. And this one is 22 minutes, but we just have time for this one, which is 1 minute. Almost 1 minute, I guess. 2 minutes, sorry.
We have two variables. X, which describes the percentage by which a country's economy went up or down over the year, and Y, which describes the percentage by which the stock market value changed that year. For X, we have the following values: 1, -1, 2, 3, and 5. For Y, we have 3, -3, 4, 6, and 9. In other words, when the economy grew by 1%, the stock market went up by 3%. When the economy fell by 1%, the stock market fell 2%, and so on. We essentially picked 5 random years from our database with the economic growth rate and stock market growth rate in each case. Variables can be positively related when they move in the same direction, inversely related if one moves in the opposite direction of the other, or of course, there is no such relationship between. Simply put, covariance tells us if variables are positively or inversely related. Correlation tells us the same thing, but also to which degree they move together. But more on that in a bit. Just remember that the covariance is used when calculating the correlation coefficient. To calculate the covariance, we use a formula which may seem complicated, but is actually quite simple once you understand what each component means. In our case, mean X and mean Y are simply the means of our numbers. So 1 minus 1 plus 2 plus 3 plus 5 divided by 5 for X, and 3 minus 2 plus 4 plus 6 plus 9 divided by 5 for Y. As such, mean X is 2 and mean Y is 4. N minus 1 is the number of values minus 1, so in our case, 5 minus 1, which is 4. please note that we does not buy in and really question represent the entire data set, or if we depend is picked randomly, like in our case, we divide by n minus one. After releasing the values,
Okay,
we
just
for simple
look at this one, this gentleman, that's 11 minutes. This is the second video. And comparing the price of banana and apple and the covariance that they have. If we get to, I'm sorry, it's here. Into this one, we just go through the first few seconds of it.
Welcome back to this class. NumPy stat on Python. This lecture, we're going to look at how to sample from a general multivariate normal distribution, where the dimensions are not necessarily independent from one another. Recall that this means a full covariance matrix. Let's start here. Variance matrix. This means that we have a variance of 1 in the first dimension and a variance of 3 in the second dimension, and that the covariance between the two dimensions is 0.2. Now let's import the module for the multivariate. So if you look at the side-by documentation, it looks like there's a function called RVS that samples from.
So what are the values that we have here? One of them is mean and the other one is covariance, right? But there's one thing missing here because we need to have samples. It doesn't have it in the old version.
If you're looking at the document that it's on, you will also
But-
see the size thing.
But in the new version, you see that we have something as it mentioned, size. So now, just knowing, again, covariance 1, 2, 2, 5, and then the mean is 0. So we are going to, my suggestion is not a bad idea to go through this sample. You're going to create random numbers, how many? 100. With the mean of 0, 0, the covariance of this. And if you want to know more about these, I've provided 3 more videos if you watch them. But the whole idea is not going through the math, just understand the Python part of it. If you run all these, let me just go through it. There is one that I did. The shape of X would be 100 as in the, but 2 columns. And if you say what is X, it's going to show you 100 rows and 2 columns, the way that you see here. So give yourself time. Try it. And whenever you get the same result, give me a signal. Thank you. Yes, up to this. Thank you. For the next part, because I thought that maybe it could help us to understand what is happening, let's just drag and drop these 3 lines. We are in page 81. These 3 lines, just drag and drop. And then instead of using a scatter plot X column number 1 index 0 and column number 2 index 1. Instead of that, just say scatter plot 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And see, it's going to show you something like this. Okay, so you see that 0, 1, 2, 3. And you may say, what if these numbers are 2, 4, 6, and 8? And run it again. Look at the result. 1, 2, 2, 4, and so on, right? Does that make sense? Okay, I'm not gonna explain anything. Let's have 5-10 minutes. You have this part, you can just apply it. And then you have all this all the way to modifying values with fancy indexing. Everything all the way to this part. Try it and see if you get similar results. First thing, and then try to understand what is happening here. Talk to your friend after finishing. Anybody volunteer? Yes, Pavan?
So we have 2 columns.
Mhm.
The capital X less. Where you say every single one column and every single one from the other.
Let me just see if I got it correctly. So you remember we said X and it had something like this, which we had. How many rows did we have?
I think it's 100.
100 and 2 columns, so it's gonna be index
Yes.
0, index 1, right? Okay, I got it so far.
That's it right there. and then you pull every index from 0 to 100, so 0 to 99, right?
True.
And then those are either the X or the Y axis.
So we are gonna pick, for instance, row number 0, this element and this element, right?
Yeah.
And then you go to the next one, this element and this element, huh? Awesome.
So it looks like at some point, we have something like -6. I can't see the X axis.
I'm talking it,
Sorry.
right?
So somewhere we have like -6, -3.
Uh-huh.
There, that's like one of the value pairs somewhere.
True.
Is -x, -3, and then the maximum, which I think is covered by the bar right now, is something like 8 and 2. And then everything
Lovely.
else is just somewhere in between.
Excellent. I got that part. So, what actually, Alvin said is, imagine that this example that we did together, we had some numbers, it's a kind of pair of X's and Y's that they are going to provide something like this, a scatter plot. But in this example, we got, you remember the X that I showed you had 100 rows, 2 columns. So let's pick the first column, index number 0, the second column, index number 1. So these guys are responsible to provide those things, right? So 100 spots, X and Y of those. And then what about this? So I just showed here, if we say everything, column number 1, these are the numbers, you can try that for everything. I mean, all the rows, column number 0, the same thing. And if you say that, what is the shape of index 0? Means that we have 100 values in this and 100 values in this for sure. But the rest of the command, that's what I paused. This is what I saw. I don't know what is this one. I don't know what is this one, and what is the meaning of replace equal to false? Repeatable value equal to false. How about 1 minute, 2 minutes of homework? Searching, talking to your neighbors, and this time let's have another winner. Maybe Marcy. Okay, so work on it for 1 minute. Okay. Any volunteer for that part? Marcy, yes.
So, it's gonna take, 100, rows, from 100 values from 0 index.
First thing, what is this X dot shape value?
It's we put where is one? It's up there, X dot shape, we take 100 values there.
We have 100 values over the right. So what is this 20?
We gonna take random 20 numbers from 0 to 6.
Excellent. We are gonna pick 20 random numbers from 0 to 99, not 100, right? But there is one thing here. It says that replace is equal to false. What does it mean? Replace equals to false. Ryan, any opinion? When it says that, yes,
If you replace it false, then we get that cover up, and makes it the same value.
what's your name?
Richard.
Richard. What I understood from this, Richard, is do you see any repetition among the numbers? It's like we have a bag that contains 100 values from 0 to 99. When you randomly, you close your eyes, you pick one number from the bag. And imagine that is 90. You do not bring that ball back again into your, to your bag. Just throw it away. What about the next number? 71. You throw it away, and so on and so on. Does that make sense? So now we understood that these indices are those 20 numbers. And you're going to use that as the fancy indexes for X. So if you just use that, it's gonna show you, you have 20 rows and 2 columns. That's fancy indices, right? 20 rows and 2 columns. And if you want to see what are those values, these are the values. So unfortunately, the book didn't explain like that, very much directly just brought us to here. What can we see? This is something that we saw 5 minutes ago. Adding plots for these blue color spots, right? But this one, that's another point that I didn't grab. So please talk to your neighbor and see what you grab out of it. This is something that we talked about it a few seconds ago. You already know the plot for that. But for the second one, I don't. Especially if you follow all those things as Catholics. Some small house. This from Asian word about should. And by the way, I'm gonna post this one before midnight tonight. So anybody? Okay, guys, how many rows do we have here? 100. How many? 100. So it's gonna be the intersection of those X and Y kind of thing. So X0, X1, which could be something like X and Y. But this time we use something like alpha. And if you see that the dots that we have here, they are not very much, saturated. They are very much transparent. Because the default value for alpha is what? Is 1. Lovely. And now we pick those 20 dots and we say, let's have a size of circle around them, 200. That's the marker size. And let's make it kind of just no color. It's not going to show that much, especially in the newer version of the Python, but if you change it to something like white or green, you can easily see the value. So imagine that we take 20 random values, and it's gonna be something like that. Okay? Please just change the values to what I have. Let me just put this guy up. Is it fine? Those who could get similar result, please just give me a signal. Merci, bravo, awesome, thank you. Excellent.
So, Professor,
Yes,
the scalar graph is gonna show the like common between zones, right? This graph.
we randomly just picked some numbers and we wanted to practice what we learned fancy indexing, right? Just this is just for the practice of fancy indexing. Yeah. Look at here because we just used selection as we go to the original indices that we had. We just said, let's have those indices, technically fancy indices, applying it on this one and bring those selection and put it into. Yeah. Okay, the next part is modifying values with fancy indices, and it is kind of confusing. Everyone, please use x equal to numpy range 10. And if you define something like one array, numpy array that contains 2, 1, 8, 4, and use it as the index or indices for array X, what's going to happen if you say place 99 into I? Explain that to your friends, your neighbors, maybe. Okay, because we are here and I want to make sure that we finish the content, it's going to take something like 5-10 minutes before we go to the first break. But what are these values? They are just indices for this array, right? We say, let's go to the NumPy. We say that index 2, index 1, index 8, and index 4. Work on those indices. What are those indices? It's going to be here, here, 1, 2. What is the other one? 8, so it's gonna be this one, and 4, it's gonna be this one, right? 0, 1, 2, 3, 4, sorry, this one. All right. My apologies. The numbers are going because they start from 0. The numbers of the indices are going to be equal to the number of, so it's going to be 1, 2, 4, and 8. If you say place 99 to those indices, what's going to happen? It is going to go to all those indices and replace them with 99. Everything is clear? What if you say go to those indices and deduct 10? It's like minus 10 for every single place that we have there. So 99 is going to turn to 89 and so on and so forth. Does that make sense? But the part that I couldn't very much, and it's a little bit confusing. Anybody can tell me where is the 4 value? Actually, I said go to 0 and convert it to 4, and then go to 0 and convert it to 6, but there's no sign of 4. Why? Yes. Except Martians, Negin. Let me just see how many bonus marks do you have. Negin, you still have, yeah, you can just say.
I'm not sure, but I think 0 and 0 is the like 0 for row and 0 for column. It's gonna be the first element, and it's gonna first write the 4, and then maybe later it's gonna overwrite by 6.
%50 of the logic was completely correct. 50%. But do we have rows and columns in X?
It's an error.
Yes, Matthew.
If we write, it overrides the index 0 and 5, before, and then.
Awesome. Excellent. So let me just repeat what Matthew said. Matthew said that, hey, we go to 0, which is going to be where? This place. And we replace it with 4. I mean, replace the value with 4. And then we go again to 0 and we put this value 6 there. So it's going to override the previous value, which was 4 a second ago. Huh? So it was 0 at the beginning. We placed 4 and then we override it with 6, and now we have 6. But this one is completely acceptable and understandable. But how about this one? Look at this. I said go to 2. I can't hide it, unfortunately. Okay, guys, try not to look at the answer. I say go to 2, index 2, which is going to be 0, 1, 2. Then go for index 3, which is going to be 0, 1, 2, 3. 2 times go there, and 4 times go there, and add 1 into it. Matthew, you wanted to say something? Somebody? Nobody? So why? I expected to have 1 here, that's fine, because it was index 2. But here I called 3 2 times. So I expected to have what? 2 here, and I expected to have 3 here because we have 3 index 4. Why it doesn't work like? Yes, Peter. Does it once? What if I want to do it 2 times? Why does it once? Yes.
So it's just taken from the previous and then you replace it with 0 plus 1, 0 plus 1.
Let me see if I NS. Let's see if I understood what you said correctly. What is this xi? It says that xi plus equal to what? 1. Can we say it is something like xi is equal to xi plus 1, right? Technically means, hey, for this one, for I equal to 3, whatever you have in that location, index number 3, what do we have there? 0 plus 1. And you do it again, you say that xi, so, hey, what do we have in xi? 0 plus 1, again, it's gonna be 1. This guy is a label to that index, right? To say that, hey, what do we have there? It is 1. And if you ask several times, it's okay, go to that index, add 1 into it. What do you have there? 0. At the same time, you do the same thing. You open it, still 0. If you do it 1,000 times, it's like, I mean, open the fridge, whatever you have there, add 1 into it. Everything happens in parallel. Does that make sense? So now the question is, what if I actually want to add 2 times or 3 times like this? Good, that's one solution. We have actually something that you see it here. We say numpy add at. At array x, these indices 1. So please try this, and you see they're gonna have for 2, for the index 2, you have 1 because we use it once. We have 2, we have 2 indices for 3, and 3 for 4. So this is the result. It's a good thing for, yeah, for discussion. Just explain what you learned to your friend. Whenever you are done with discussion, instead of 1, say 5 and see the result. Add 5 to that index. Done? Okay, so it's on page, while you are talking to your friends, it's on page 83. I strongly suggest that whatever we discussed is briefly mentioned in this paragraph. I'm gonna close my laptop for a second, and meanwhile, you can read that. This is group number, oopsie, let me just stop sharing. I've forgotten to stop sharing first. Okay, so let me quickly go through. Abhishek. Abhishek. Adina. Berniel. Carl, right? Casey's there. Diego was there, just went a few seconds ago out. Enes is here. Ivan, James. Ivan James? Yes? Okay, awesome. Gaurav. Arlen is there. Arsh. UI is there. You. Point. HUY, and H. Yana or Lana? No, Yana. James left. John Seltzer. Josephine is not here. Carl with K, yes. And then Khadija is here. Kidus. Koichi. Kushal Patel. Lucas Kenji. Oh, thank you. So Koichi is not here, right? Okay. Maharshi is here. Mashad is here. Mahir is here. Matthew is Mark. Mark. And Mega. Matthew is here. Okay. Meha is not here. Muhammad Taloy is not here. Mustafa Ismail is not here. Nanami. Nagin is here. Oven is here. Pavan Kumar. Peter is here. Raleigh is here. Richard. Yeah. RJ Rose. Ryan Yu is here. Sabrina is here. Shada is not here. Stefan is here. Tafadz not here. Tai Kaivu. Thank you. Kami is here. Vincent. Thank you. Yang is here. Okay, can you please do me a favor? Anybody from other sections? 2 of you are from 8 to 11, right? Rachel is here too, so let me just. Rachel is here, 0 for the other person. Is 1 and Okay, everybody, can you please check your lab exercise mark if everything is fine with it? Thank you. Sorry. Add class is H1R0. Would you please try add class 2? It works? Okay, so add class works and your marks are fine. Excellent. So by saying that, let me just save again. Let's have 10 minutes break. And then we are gonna come back. Let's say 12:30, sharp 12:30 and continue. Thank you. Merci, merci. Catherine, tell us a fast nمیشم. Will you tell us if they're going? Don't worry. So don't worry. Just on this. Okay, sure. What is the section number? That's
Section 8.
2. It says 92, right? That's, I think, Peter. No, it's not this one.
It's 91.
Oops. 91, Peter. I checked the other things, but this one is the only thing that left. Where is the, I think it's here. So can you please check? It should be okay now.
I actually try, I asked you why I haven't made. I try to that in terminals and works and just pops a pop-up window with.
Nice. Yeah, don't worry, those things are completely acceptable and
No, I tried it.
Happens,
I
right?
tried it in 3 different ways.
nice.
You know, like,
Nice, okay. So everything is fine now, right?
Yeah.
Excellent. I'm gonna share the screen. فقط برای کلاس شما پیش میاد ندارم محمد حالا تازه جالبه من نمیگم که مدافعش هم اونجاست. نیستی؟ یه نفوذی داریم خب دیگه خب. آخ گفتی
یکم که زیاد خیلی زیاد یکم
قربون شکلت اینایی که توی سوشال میدیا میگن رو بذار ما تکرار نکنین. چرا؟ به خاطر که مثلا میگن تورم کانادا. حالا مثلا من فکر میکنه من 10 سال پیش فلافل میخوردم $4 الان شده $6 11. این کجا نداره یک بعد تو با اینکه آیا مثلا خب من 11 سال پیش درآمدم با الان چرا خیلی فرق داره.
آخه من نمی‌دونم من یک سال پیش
اون اصلا قیاس نکن. بذار بگم چرا. نه. بذار بگم دقیقاً چرا. شما زمانی اومدید که قیمت مسکن یهو اینطوری اومد پایین به خاطر کرونا. یعنی خونه ای که 2400 500 تا بود طرف التماس میگه 1500 تا کسی بگیرید. بعد دقیقاً شما تو زمانی اومدی که التماس می‌کردن. بعد دوباره برگشت به قسمت عادی ماجرا نه اینکه مثلا یعنی شما الان عادی شده. بزنین بعد از اینکه داستان شده ببینیم ولی یه ایرادی هستش. ما توی ایران 2 تا مکان داریم. یکی ایران یکی خارج. که خارج قرار همه چیزش ایدئال باشه و وقتی که میان ایرانی‌ها میان خارج معمولا هم با ترکیب زی اینطوری گفته میشه خارج. وقتی میان خارج میبینن که نه این مثلا خیلی هم چیز نیست. آن که فکر می‌کردن نیست. همون در واقع نه مثل هر جای دیگه سه چیز خوب داره سه چیز بد داره ولی معدل قابل قبوله. من فقط اینطوری میگم. ببین معدلش قابل. اوکی. After the class, we're going to chit chat. Oh, by the way, that's a good thing that we recorded these conversations, but people are not going to understand because it's Persian. Okay, guys, before the official starts, you have seen let me just share with you. I think that can you see the screen? Yes, you can. If you go to the course contents that I have provided for you in any of these, let's just open. If you check in the course content, we have NumPy that whatever we needed are already uploaded, right? And the thing is, guys, today, by the end of tonight, maximum, you're gonna see there is no sign of parts A, parts B, because I'm gonna replace them all with just total, not part. And the version that I made is 2.1, and the reason for that is I've changed some of the stuff. I added some contents to it, including videos. So that's why you're gonna have just one file. Apart from it, you see we have scikit-learn. I have provided these 4 files, but I try my best. I have a plan to make it kind of nice, neat example that you can use for, what do you call it? For your assignment number 2. I told you people found it a little bit confusing. I don't want to leave you just with questions. Next week, we try to finish all these 4 slides, plus we will try our best to do some step-by-step stuff. Apart from it, I already mentioned several times and I announced it, but quiz number 5 is uploaded. You have seen that, right? Because there's a chance that people forget and they think that because we didn't have any lecture, there's no quiz. I just extend the deadline to next week, Wednesday. So next week, if somebody wants to answer their quiz, eventually they're gonna see that there are two quizzes, quiz number 5 and 6. Okay? That's pretty much it. Is everything clear for you? How to find the quizzes, the assignments, everything is fine? Yeah? Easy to follow? So that's one thing, and apart from it, I just spend 1 minute before we proceed, and that is for. I remember because actually I was thinking yesterday, last year, that there are something happening in the country that I grew up. I couldn't concentrate at all. I remember those days I was just at the computer, checking the news here, there, receiving the. And I completely understand people who are from different part of the globe and they could have issues, people in Middle East, people in Russia or Ukraine. So if there's any friend that's from those regions and they have beloved ones and they worry about them and they cannot concentrate, if they need any extension for any of the things that we have together, please let me know. I try to collaborate as best as I can. And I'm gonna kick it off by just saying one thing. I don't know when this stupidity is gonna be over, because Milan Kundera, the author that I very much like, passed away unfortunately a few months ago. There's one golden sentence I always remember. He said, "The thing that is not a matter of your choice, no need to be proud of, no need to be ashamed of, like your race, the region that you grew up, or something like this." Hopefully people are gonna be more reasonable and love each other more. Hopefully. Let's go to the next parts together. And that's the data binding. What is data binding? It's the continuation of what we learned in universal functions. Everybody, please try all these lines. I'm gonna explain everything. It tries to use fancy indexing that we have learned, and using those. Do you remember here we said this doesn't work and we need to use add at? It tries to use exactly the same concept. So please run all these lines. You should receive something similar to mine. And if that is the case, please give me a signal. Apart from it, you see, I mentioned a few extra things like having X here. Done. Problem. Let's see. You can take your time if you get any error. Okay, can I have your attention, please? Correct me if I'm making any mistake. We are going to have one seed 42. That all of us are going to get similar results. We generate 100 random numbers between 0 to 1. Sorry, it's not random. It's normalized random. So the center would be 0, but it's going to be from something like minus, as you see here, the numbers that we have, they're going to be between something like -3, mostly -2, -1, something, all the way to 1, 2, 3. So those random numbers, 100, remember, it's not random, it is rand n, which is normalized form of random. And when it is normalized form of random, means that distribution would be almost equally distributed, and the center would be 0. If you just calculate to me, look at this one here. We say line space between -5 to 5. Let's slice it into 20 different portions, and then we what does it mean? Anybody can tell? What's the meaning of this line? Let me just run all these things that we have done so far. Did we use it today? I think that we used it. Yeah, we used it, but not here. Excellent, yeah. Oops. NumPy dot zeros. Let's just say oh, that's because we didn't make it what do we call it? An array. That's the problem. Okay, so I just wanted to test one thing. Can anybody tell me what is happening here inside count equal to zeros, like bins? Yes.
It's gonna be the same dimensions as the pencil.
Excellent. Yes, guys, it is the job for us to say, hey, let's create one array. All of the elements should be zeros, but the size of that would be equal to bins, which is going to be 20 kind of things. Does that make sense? Look at this one. You say the bins is equal to line space from -5 to 5. Let's chop it into 20 different segments. And then you're going to say, let's do the same thing. Let's have an array of 20 zeros, but instead of just giving hard time, we say that we need to have the same dimension of bins. Mr. Wright. Or okay, so if you run that and if you say that, okay, what is the bins? It shows you -5 all the way to 5, and constant, it's going to show you 20 zeros. The next part is we say, hey, go to the bins and pick those X values. What are X values that we have? Guys, remember 100X values? What is the first value that we have here? Negin, what is the first value? 0.49. Listen, I'm going to come to this array, which is 20 segments, and bring this one. If you look at 0.49, it is, what is this index? Index 0, index 1, 2, 3, 4. This is going to be 9, 10, and this is 11, right? You see that this is 11. Go and search in the bins that we have. What is the ceiling for that value? The ceiling for that value is index 11. Look at here, it is going to be 11. How about the next number that we have here? The next number is negative 0.13. And if you see, the ceiling for that one would be this, index 10. It is more than this, less than this. The ceiling for that is this one. Does that make sense? Index 10, so that is why we have 10. What is the next number? Tell me. The next number here is 0.64. No need to repeat. You see exactly index 11 is the ceiling for that too. So that is why we have 11, 10, 11, and so on and so forth. Does that make sense? So we have 100 values that each of them shows which one is the closest bin for the value that we have among those 100 random numbers. Gaurav, does that make sense? Okay, so here what we do is go to the count. What is count? Those 20 zeros. And go to the index, like index 11, add 1 into it, index 10, add 1 into it, index 11, again, it's going to be 2, index 13, now it's going to be 1. Add 1 into every single elements that you see inside this, right? Inside I vector, fetch any one of them and add value to the count to the relevant index of that. Does that make sense? By saying that, you're going to have something like this. And then simply you're going to say, hey, plot for me. You're going to have bins. That is my -5 to 5. And the line style is dash dash. And then the draw style is steps. And then we say just simply plot. Right? Okay. But this is crazy if you want to have a simple plot every time you go through all those steps. A shortcut for that is, let's have X values and let's have bins, which is between -5 to 5, 20 times, and then type histogram. Automatically, it is going to place those values into bins. And you see, it's pretty similar to the sample that we created a few seconds ago. My suggestion is now spend 2-3 minutes right now, go through the code and explain everything to your neighbor.
Maybe we find I equal to. So just check in line by line, my suggestion is, and we're gonna vote on it after the meeting, so still we have that issue. But for any one of them, split it into two cells, say what is beans now, here, what is counts now, so as you did, and then what is I? It's not correct. I is not this one. Search pins inside. Can you please go this one? Thank you. So, it should be something like this, not two. Search. What is this? Search. NumPy. Search sorted bins. You use capital X. It should be small x. Sir. No worries. Okay. Because we had one capital X before, that's the reason. Okie doke. So the good thing is the class is recorded, but guys, these things are not easy very much. One question here, if you see the time it, okay. So how about this one? Nice guys. If you check, you see that NumPy mechanism to write histogram takes 25, but that handmade function that we created takes less time. What is your understanding? Why? Okay. Maharshi, what is your understanding? Why this one takes more time compared to something that we created ourselves? Technically, we expect what NumPy generates should be more efficient compared to what we generate. But why it's not the case here? Yes.
Because it's search sorted, so it has to search and sort first, but the other one is already it's ready, so it's less.
They do the same thing. Actually, this is like we just show what is happening behind the scene in NumPy. But do this one, use x equal to random rand normal 1 million, and then calculate, use time it for using NumPy routine and for that handmade mechanism that we had. Then if you just compare these two, you're gonna see NumPy provides way faster, higher performance compared to man-made or our own defined routine. So I want you to compare these two and have your own rationale
why we have this result. What can you infer from it? Any idea? I think that Lucas can answer that.
Well, isn't that just like built in like my stuff is faster, like, well, I don't know exactly why, but I do it for a little back. It's less time.
You're correct. The thing is, actually, NumPy is faster, but it is designed to work with huge data sets. When you work with a small data set, the overhead, because it does some behind the scene type checking and so on, which is going to lower down the speed. So it is designed to work faster, but when the scale of the data set is huge. Okay, does that make sense? That is why you see when we have 1 million random numbers, the NumPy mechanism runs faster compared to that what we defined ourselves. Okay, now let's go to the sorting. And what is this sorting? Anybody can explain what is happening here? And what is the order of this one? What is the big O of these sorts? Pardon me? O of n. Do you think that we have sorts n with order of n? If somebody can find that, it's going to be a revolution in computer science. The big O of n power of 2. Okay, now the question is why it is n power of 2. Because what I see here is just one loop, 1, 4, nothing more. So why you say it is n to the power of 2? Anyone? What is the order? Some people say it is n, and the reason that they said n, I guess, because there is 1, 4 here.
It should be n squared, right?
Why it is n squared?
Because we are looking through X, then we are moving through unsorted array to
I can't get it. Where is the second loop?
and we don't have the second like top line. Are we gonna move through unsorted and
Okay, let's just go through it together. As Maharshi said, we have one loop here. Yes, 4. I from 0 all the way to the end of the array. But the other loop that we have goes to this one. We say for every I, go and find the smallest, the minimum argument that we have, the minimum index that the value is the lowest. So go from 0 all the way to the end. This is another loop. It's like saying for loop from 0 all the way to the end. And you find the minimum, and then you swap the values. And then again, you go to the next one, number 2. You start from 2 all the way to the end. And again, so it's going to be n to the power of 2 n squares. So let's try this one. Let's try this one and say selection sort. This is handwritten sort. And make sure that you get the same result. And whenever you are done, just give me a signal. Let's see. Done. Okay. Somebody tells me, what is this one? What kind of sort is this? Okay. Well, nobody's gonna write code like this for sure, but I want you to try this one with your friend and see what is happening in here. Imagine that the array that we have is like this: 1, 2, 3, 4, and 5. That is the sorted version of the array. Yes?
So it's gonna find all the possible ways of finding if it's sorted or not, and then it determines if it's sorted or not.
Finding all the, the way that you say it's like, I mean, we store them somewhere. Do we store them actually? Somewhere? This? How about this? Let's just have brainstorm with our neighbors and after the next. Sabri, do you have any opinion? Well, this. Me too. Ready to have what? You're laughing. You have to say. Guys, you relax. I found somebody who's gonna. Okay. Let me just ask you one. Guys, look at this one. What is this? It's gonna do shuffling, right? Yes.
Explain one more time.
Sorry,
Can I explain one more
please, go ahead.
time? It basically generates permutations of the list or whatever is trying to be sorted. It's gonna, as you said, shuffle. It's gonna randomly generate, finds the correct list.
Excellent. And how we can recognize if it is correct or not, that is the key point. The key point, imagine that one of the, I'm just saying one of the random possibility could be, for instance, 1, 2, 3, 5, and 4. We are not very much lucky. One of the numbers are just different, right? Listen to me. Here we say X from the beginning all the way to the end, but 1 before the last element, which is going to be what? Which is going to be 1, 2, 3, and 5, but not 4. What is the second one? The second one says from index 1, which is going to be 2, 3, 5, and 4. Does that make sense? For this one, all of these guys should be, this one should be greater than this, which is correct. This one should be greater than this, which is correct. This one should be greater than this, which is correct. But how about this one? Still, just because of 1. It took something like less than a second, but because we try all the possibilities. Huh? One of the friends in one of the classes in the previous semester, he was kind enough to try, and I have the name here, yes, Carter. We tried it with 100,000, and I think that at the beginning of the class, he started, and after 2-3 hours, still it was working. So because it's huge, you know, randomness is, it's not easy to find. Okay. So everybody please try that. برهان نظم که میگفتیم. برهان نظم. ممکن است. Okay, try this one. Not a bad idea. Time it. Done? Okay. So let's see what we have here. If you say numpy dot array this and it's x. If you say numpy dot sort x, is it going to change the values in the array? Means is it going to sort in place? Actually, no. But if you want to sort it, you have to say, hey, go to that array and sort it. Treat it like this. Right? So in that case, if you prefer to sort the array in place, you can instead use the sort method of arrays. Okay, the other way is simply say x is equal to numpy, numpy dot sort x. This is another way. You can replace the current x with a sorted version. Does that make sense? Awesome. What is this one? Arg sort. Excellent. It's going to say, for instance, now go and sort the indices. Which one is the smallest number? 1. What is the index of that? 1. So that is why. What is the second smallest? 2. Which the index is 0. What is the third smallest number? And the index is 3. And then 2. And then, does that make sense? Okay. What is the next one? It says that xi, very simple, fancy indexing. This is going to make the array sorted for you. Does that make sense? What is the use of it? You want to see, for instance, among 7 weeks, seven days that we have in a week, which day we have the maximum number of customers, for example. You're gonna see that number by checking arg sort. Okay. This one, please everybody run these lines and explain to your neighbor what is happening here and why your numbers are identical. Is there any reason for it? Done? Megan, do you want to explain it?
So we're gonna, we have 4 rows and 6 columns.
4 rows and 6 columns of random numbers.
And the range is 0 to 10.
Is it going to be inclusive or exclusive for the 10 side? 10. Awesome. So that's why we have 4 rows. And
And we get the same result because we have the CD for the random state.
excellent, because we have random state 42, similar to saying seed. And what is this one? Actually, this is a little bit, let's get to this place, then we can easily see. Okay, there we go. This is the original value, 6, 3, 7, and here you say sort x, axis equal to 0. What does it mean? Yes, Lucas.
In that, final row, we place below the, matrix. Do that.
It means that we are going to collapse it like it's sorted based on, so that is why it's gonna be 2, 5, 6, 7, 1, 2, 3, 6, and so on. Just remember, by doing that, we technically break the relationship between every single row. If those values like 6, 3, 7, 4, 6, 9, they belong to, for instance, Reza, then you just change the order, and I cannot find those numbers that belong to my record. It's not gonna be record anymore. Just we need to be careful of that. Huh? How about this one? I'm not gonna take the time. It's gonna do it in a column. If you say axis equal to 1. So it is sorted 3, 4, 6, 6, 7, 9. 2, 3, 4, 6, 7, 7. Yes.
So, usually where we're gonna like use sorting like, the cases in one column, right?
Okay, imagine that we have different stocks, right? And in different, what do we call it, days, we want to see what was the minimum value for that stock and what was the maximum value for that stock. And for us, it's not important to see in one, for instance, a week or so. We want to see in a whole year, what was the values that we experienced, right? Something like that. And how about partial sort? This is super important. Imagine that we say x is equal to numpy array. Those are the values. If you say x3 means 1, 2, 3, let's just have all the numbers, and the funny thing is the numbers below that value are gonna be arbitrary. It's not like 1, 2, 3. It's like if you divide it into 2 parts, this is arbitrary, not sorted, this is not sorted. You can just say what are the numbers are, unless you partition it into 2 parts. Let me just read that for you from the book. And it mentioned it beautifully that sometimes we are not interested in sorting the entire array, but simply wants to find the k smallest, means, for instance, in that example, 3 smallest values. And for us, it's not important to sort it. You may say, Reza, I want to first find the k smallest numbers, and second, I want to sort them. So you can do it in 2 steps, right? Now here, and the thing is, what is the usage for that, for example? To pick the maximum 8 quizzes out of 11, right? Or to take out 3 minimum quizzes, keep the rest, something like that. Does that make sense? Yes.
Is that 3 exclusive?
Well, it's not value 3, it's 3,
Index.
it's 3 smallest values. Right? So randomly we had 1, 3 over there as well, but it's 3. And is it possible to do it? Look at here. Let's have partition 2 smallest values, 3 and 4, 2 and 3, 1 and 2, 0 and 1, and the rest. And they are not sorted, right? Does that make sense, everybody? This part needs lots of math. I don't very much recommend to page 88 all the way to the end of 89 and a little bit of, sorry, until just this part of page 92. This part is not going to be part of our midterm. Just read it at your convenience. But because we are going to learn k-nearest neighbors in examples in scikit-learn in a simpler version. So let's just, learn it there. Okay. But now we want to talk about the big O notation. Anybody knows about big O, omega, theta, which one is the best case, which one is the worst case, which one is the middle case, average case? Yes.
Yeah, like the general idea is just to determine the time complexity of an algorithm. And the purpose of that is to see that as the data set increases or as the input increases, how much more time is required for the increase to take place. The algorithm to execute. So the best case scenario, there's some algorithms that are constantly finding that regardless of the size of your initial input, you will execute the same amount of time. And then there's some that say if you double the input, you will the power to double the output time. So maybe it's not practical for large data sets, whereas it's just, I'm not good at calculating it, but I know it's practical.
I most like your explanation. Nice. The thing is, if you want to, what you said actually was generally about big O notation. But what is the best case? What is the worst case? What is the average case? There are some, Lucas, there are some, whatchamacallit, specific terms for them. Anyone? Now let me tell you one thing, you have all passed data structure, right? Okay, many. But when I ask people from, graduates from universities and bachelor level, master level, and I ask them, okay, just in a simple example, tell me, which one is faster, log or n? So tell me, which one is faster, log or n? Log n or m. Which one is faster, you said? How many of you say log n is faster? 1, 2, 3, 4. Okay. 5.5. How many of you say n is faster? And 1, 2, 3, 4. So the rest are shy, right? So okay, let's wait, see what's gonna happen. So 4. Good. Almost similar. Look at this one. And remember this example. This is going to be whenever anybody asks you. Imagine that we have an array. This is 0 all the way to 127. Okay. Masha, pick one number between 0 to 127. 15. 50, which is almost here, 50, right? How many times should I knock the door to get to 50 if I want to start from 0, 1, 2, 3? Tell me. It's going to be 51. Why? Because we start from 0. Am I right? So it's gonna be 51. Pick another number. 75, right? So it's gonna be 75. Pick another number if you want. Sorry? 100, right? So you see that, guys, even one random is not very much random. I ask you, sometimes we are lucky this number is closer to the beginning, sometimes it is closer to the end. In average, we could say we have to go almost, I'm not saying exactly, we have to go almost 74, 75 times, right? Something in the middle. Acceptable? Okay, so in average, in that case, it is 75. But look at this one. This time, do not tell me. Can you please just, both of you, yes, bring the calculator up. I'm gonna ask you to calculate something for me. Okay? Thank you very much. I'm sorry to give you burden. So this time, Stefan, pick a number between 0 to 125 and 27 and don't tell me. Picked it? Okay, awesome. Is that number less than or equal 64? It's more. Okay, so we are here. Please add these two numbers, 64, 127. This was one guess. And divided by 2. Should be 90 something. 95. 95. Okay. Is that number less than or equal 95? Less than 95 plus 64 divided by 2. So it is 2. 79. Is that number less than or equal to? It's more 70. So it was number 3 guess. Add these two numbers divided by 2. 79 plus 90. 87. Is that number less than or equal to? That is the number, right? This time I was lucky, but I'm telling you, I could go just 3 more steps and make the number of guesses 7. Guys, the number that we are talking was 87. If I wanted to go and knock the door one by one, I have to knock 88 doors to find this one. Right now, well, I was lucky, but right now I could guess it after 4 attempts. Does that make sense? So this one was log n. This one was n. Now I ask you again, which one is faster? So there is one thing. There is one thing, and you saw that n log n, sometimes we have n log n, the multiplication, and then n2. That is one explanation. The other explanation that you need to tell people, what is the difference between n and n2? How you describe it, knowing the, yeah.
N2 or N raised to
N to the power of n squared. Yes.
There will be 2 loops.
Like whenever we have 2 loops, but how you explain it in by using some numbers. Listen to me. If you have 1,000 records and it takes 1 second, if the big O is n, if you multiply it by 2, right? What do you expect as the amount of time that you need to spend this time? 2, if it is order n. It is going to be linear. Does that make sense? But what if the order is n2? If you double the value, the expected time for this would be 2 to the power of 2, which is 4. Does that make sense? So it's gonna be exponential. Right? Does that make sense? So the last thing that I want to tell, and just these are not the things, but guys, I was like you. I needed to pass this data structure, and I had lots of stress. I remember the time that I had that exam, and I told my friends that, hey, if the prof tells me that he's going to fail me with something around 15, like 49, 48, I'm not going to go to exam. I'm happy with that. Honestly, I remember. And that's one of the courses that I had nightmare way after passing it. So, but these are the gist of the things that stays with me till this moment. And we need those things, not the details that you need to learn for passing the course. The last thing that these are the questions in interviews, they very much like, this is O, this is omega, and this is theta. Okay, intentionally I wrote it that way. Which one is the best? Which one is the worst? Which one is the average? Sorry? Omega. Today is not your day. Don't buy any lottery or something. Someone. So, can I have everybody's attention? Hopefully you're gonna remember it the way that I. Guys, do you know the brand for watch Omega?
Yeah.
That's one of the best. So always remember, this is the best case, okay? Guys, this is like you guys in the middle of the class watching your watch and saying that it's just half of the way through the, so it is average. It's like this. So this is the average case. And this is, oops. You got it, worst case scenario, best case scenario, and average. Just write a note for yourself somewhere. The last thing that I want to tell, and I'm not going to very much emphasize on that, would be why you say some of the stuff you say. I don't want to emphasize because we will have a better version using handouts. But we need to just be familiar. Yes, whether you want it or not, you're going to see some code here and there. You just need to understand. Structured array is something that you see mostly. Record array, forget it. Listen to me, Ali. We have name, age, and weight. Do you see any relationship between all these guys?
Age and weight.
Actually, no. Lucas.
I mean, I'm just looking at this and saying that columns. So that it's there. Each of these values for Alice, 25. That's the only relationship.
Very much like okay. And again, do you see that relationship that Lucas mentioned? Means that we have 4 people. Who are they? Alice and Dalton, right? Alice is 25, Bob is 45, and these are their weights. But this is something that we could come up with because they have the same number of columns. Let's look at that. But is there any kind of link that add them all together and say, okay, this is like data set? Do you see such a link? we are going to make. Look at this one. If you say numpy dot zero score, what's going to happen? It's going to create X that contains 4 zeros. Lovely. What if we say, let's create data, result? Well, the name is not reserved word, anything, ABC, equal to zeros, but look at this part. We are going to have how many? How many? 4 values, and this is a dictionary that we use names and type. The names of the fields would be name, age, and weight. You see that? And the type is going to be UTF-8, 10 characters. Means string 10 characters. Let's just simplify. This one, integer 4 bytes, float 8 bytes. Huh? You follow, everyone? Now we have, it's like we have 4 books and we have 4 shelves, and we want to place those books into the shelves. Before that, if you say what are the types of each of those guys, it's going to say the first one is a string, 10 characters, age, integer, and weight. Right? Good. It's going to explain in no time, so just a few seconds.
It's just pointing out.
And now it's the time we have frame, and we can just say Alice, Bob, the other 2. Because we have 4 zeros, 4 spaces for it, right? Place them in here. Age 24, 25, 45, and so on. Place them here. Weight, place them here. 55, and so on. Does that make sense? Now, those people, it's like, what is your name? Alice. How old are you? 25. What is your weight? 55 kilograms. And if you say, please print the data, now you can see easily that we are talking about 1 record, 2nd record, and 3rd record. Right? Please apply all these things. Please try it. Done? Whenever you are done, please give me a signal. Merci, Gaurav. Gaurav, you are the only person who just you submit before opening the folder. Am I right? Awesome. Thanks for hard working. Okay. Let's go to the next part. How about this? If you say, I want to see what we have in the data field of the structure. By the way, we call it structured array. So what are we going to have if we say data.name means show me Alice, Bob, Kathy, and Tom. The other thing is, what if I say, what do we have as the first record, first element of the structured array? It's going to point Al is 25. Is it possible that we use those kind of fancy indexing or masking and those kind of things? Well, apparently we can. If you just say -1, it's going to start from the last element goes towards first, right? So it's going to be dog. And then how about this one? This one, I couldn't understand what is happening here. Please talk to your neighbor and see what is happening. And a volunteer, Yang, you look like a volunteer. So be ready. Or I'm gonna ask Chloe. Just take your time, see what is happening there. Okay, I ease the job for the one who wants to explain. So, who wants to explain? Yes.
Okay, so basically we're trying to get all the names that were like your age is like under 30. And for the second line, for in this case, we should allow some middle, right? And for the second part that you read, yeah.
So it's going to say, you're going to just break it down into two parts. First, this mask part, which is going to bring true, false, false, true, right? So we are going to just include these two. These two are truth, right? And then what else? It's going to bring all the data, but we want to go to the column name, to the field name, right? So it's going to just show those two names. If we do not mention that name, it's going to show everything about those two, right? Please try it. Done? Guys, the good news is we just need 2-3 more minutes, so please be patient. Okay. Look at this one. These are the types. We already worked with this. We say if you want to create a structured array, one of the ways is using dictionary mechanism, having names and types dictionary form. For the names, we have those field or column headers kind of thing. For formats, we have the type that we're going to use. You might see the Python version or NumPy version. Whenever you have a chance to choose NumPy version, please go for NumPy, like this one. And there is a whatchamacallit, this table that shows, for instance, NumPy.data type B, it's byte. If you say I4 is integer 32 bits or 4 bytes and so on. The other format of same using a simple format. It's like name, string 10, age. You see, it's not name and format. It's like a pair of field name and the type of. That's another way. And if you do not insist to have any column header, you just need to have kind of structure that you put values. You can use this one. So string 10, integer 4, F8. by saying that technically and this table, we finish the content for today. There's one part because we do not use it that much, I just eliminate that from study. It's pretty simple. The only thing is it takes more time to execute whenever you use that data structure. So, and rarely you can see it. So that's why I just eliminate that part. Apart from it, next week we are gonna start with scikit-learn with one very famous example, and that is decision tree. Is there any concern, any question, any issue so far? And you check your marks except the bonus marks that I'm gonna update it by tonight. All the marks are already updated, right? Anybody has any issue about? Okay, thank you very much. Let's enjoy the rest of your day and see you next week.
So I make like visits ready, then they can have to.
The first is, well, you already have the difference on. My suggestion is, instead of just saying gray, yes or no, for instance, if it is just 1 millimeter, who cares? Right, so you can just have it very short for that.
Like, that's how it's supposed to be done. The final part, it says so, accuracy 1.0.
Well, actually, it's not 100%. Normally, like it has a
We go back that kind of one for
First, I tried to find CSV file. It's very big, so.